Okay, YouTube, in my last 4 videos we've been solving trigonometric equations, but doing so with equations that have, I guess, trig values that are easily found on the unit circle. And so these often have reference angles of 30, 45, and 60. We're going to look at this video at a couple of equations here that we would have to use a calculator to solve instead of a unit circle that we could use. So taking a look at these equations here, we'll start with letter A. What we want to do is solve these equations on the interval from 0 to 360. So what angles between 0 and 360 would make this true? Essentially, we're going to use the same practices we've had up until now. And so that is to say we're going to isolate the trig function if at all possible. So we have 2 times the sine of our angle would be 3 less than 4.578. So this would be 1.578. Do a little mental math here. But if I divide this in half, what we end up with is this. We get sine of x is equal to 0. Now I'm going to have to get my calculator out here. We say 1.578, so we have 1.578 divided by 2. We get roughly 0.789, so we have 789. So the question now becomes, okay, so what angles give us a sine value of positive 0.789? So first things first, what I want to recognize is if sine is positive, we have to be either in the first or the second quadrant to begin with. And second of all, what I want to do is point out that we can undo this right here, the sine function, by using an inverse sine function. So as we've been working backwards, we really have been using these inverse sine functions, but we actually get this. We get then the inverse sine of 0.789 is the x value. Now the interesting thing that we're looking for here is the angle, but what your calculator is going to tell you is a reference angle. And so if I were to type this in, first things first, let's make sure that I'm getting an angle here that's in degrees. I choose to work in degrees when I deal with these. So we'd say in degrees, if we type in the sine inverse of 0.789, then roughly what it's doing is giving you an angle that gave you this. And so we'd say, well, then the angle must have been about a 52-degree angle. And so I'm just going to roll with, say, 52.1 degrees. So we would say that at least the reference angle here, x prime, would be about 52.1 degrees. And so what I'm going to do is essentially I'm going to go up here into the first and the second quadrant, and I'm going to sketch what I know, which is that each of these angles, I'll say that they're congruent here, is about 52.1 degrees. And so since that's the case, we could say then, well, what are these angles in standard position? And that's the question we're trying to answer. And so in this case, what we're going to need to do is acknowledge that one of our angles, of course, is 52.1 degrees. But the other angle between 0 and 360 would have to be this angle that's 52.1 degrees short of 180 degrees. And so if we were to just grab our calculators here and we'd say, okay, well, you know, what if I subtracted 180 off of just our angle here? 180, you know, and I know it's got to be positive here when you look up here, but about 127.9. So we would say 127.9 degrees would be our other solution. So the neat thing about this is the same thing we've been doing, except for that our reference angles get reported to us on a calculator, by a calculator, and that we got to go sketch it and figure these out using these reference angles that we're not used to, okay? So taking a look at letter B here, basically, let's go solve for alpha. It looks like we have tangent on both sides. So I think very easily we could add a tangent of alpha to both sides. If we were to add a tangent of alpha to both sides, looks like we would have 3 tangents of alpha on the left minus 12 constants, and that would have to equal our 8 constants on the right. So now moving forward with this, if I were to add, whoops, I'm already thinking what it adds up to, add 12 to both sides here, then we would get 3 tangent of alpha would be equal to 20. And so now from here, dividing both sides by 3, we don't have to deal with a decimal. We could deal with a fraction, but what we end up with is 20/3. And so again, to undo our tangent, we're just with a calculator here. Since I recognize that the right side here isn't any tangent value that's on the unit circle that I recognize easily, then what we're going to do is we're just going to use a calculator to assist us. And so we say, you know, the tangent inverse of 20/3. Grabbing our calculator, get this guy. In degrees then, what we want to do is ask the calculator, you know, what was the angle that when I took, you know, the tangent of it, I got 20/3? And it's going to tell us here, say, about an 81.5 degree angle. So we're going to say, now, knowing our reference angle is 81.5 degrees, and also that tangent came out to be positive, where's tangent positive? Which quadrants are we in? We would have to be in quadrant 3 or 1. So we're going to go basically sketch in our reference angles here. We have an 82.5 degree angle, and I could have drawn it better, but we'd say that this is also 82.5 degrees. So then the questions become, okay then, what are our angles in standard position. So the first one here, pretty easy to discern, is 82.5 degrees. Our second angle between 0 and 360 would be 82.5 degrees past 180 degrees. And so just using a calculator here, we'd say if I were to add 180 degrees to this, what I would get is 261.5. Now, I just realized here, 261.5. Probably just a mental lapse here. These are not 82.5. These are, looks like, if I look at my calculator again here, they were 81.5. And so I'm not sure why I wrote 82.5, but these are 81.5. But we did get this second angle accurate here, and this would have to just be an 81.5 right there. But those are the angles that we get, and that's how we use a calculator to assist us in getting those. Cheers.